It doesn't look like fractions and fractions, but it's going to be in a second. Remember, when you have x to the negative n, that's the same thing as 1 over x to the positive n. So basically, a negative exponent says take the reciprocal, but you have to be careful on order of operations. For that first term, ab to the negative 2, notice that negative exponent is only on the b. This is really a times b to the negative 2. So order of operations says exponent and then multiplication. Because of that, when simplifying ab to the negative 2, only the b goes downstairs as a b squared. Now the other comment I have to make is, since this is complex fractions and we have differences in sums here, when the b squared goes downstairs, it does not cross over this big division line. It's still going to be in the numerator, a over b squared. And again, that's because you have a minus and a plus. If this was all one big product, then yeah, the b squared would cross over that big line. So doing the rest using this negative exponent rule, minus a to the negative 3 would be 1 over a cubed. A to the negative 2 times b. Just like before, only the a will go downstairs, the b will stay up. It'll be b over a squared. Plus b to the negative 1, that's 1 over b. So now it shows that we have fractions inside of fractions. So we have to find the LCD. Remember, the LCD is the product of unique factors, each raised to the highest power that they appear in any factor denominator. We have two unique factors, a and b. So now we have to raise them to the highest power that appears in any single denominator. Well, notice we have an a squared and an a cubed. Which one's bigger? Hopefully you said the cube. So our LCD will get the a cubed. Similarly, for the b's, we have a b squared and technically a b to the first. Well, 2 is bigger than 1, so our LCD will get the squared. So we're going to multiply every fraction by a cubed b squared. So again, I suggest that you write the LCD next to every term in your complex fraction. It's easier to see that way how things cancel. For the first one, we have a b squared in the denominator and a b squared technically in the numerator. Those are just going to cancel completely. But again, this is a product here, so a times a cubed is a to the fourth. For the second term, the a cubed in the denominator and the a cubed in the numerator are going to cancel. So we have 1 times b squared, which is b squared, but don't forget your minus, so minus b squared. Now the denominator, we have to be a little bit more careful. Here we have an a squared, and that's going to take out 2 of the a's from the a cubed, leaving just 1 left over. Notice I only canceled the exponent because here's my a that I'm left over with. But again, this is a product, so ab squared times another b is ab cubed. Plus, we have 1b, but we have a total of 2 b's in the LCD. So this 1b is going to cancel out 1 of the b's from the b squared, leaving still a b left over. 1 a cubed b is just a cubed b. So we are left with a to the fourth minus b squared over a b cubed plus a cubed b. A to the fourth minus b squared does actually factor. It's a difference of squares, but nothing's going to cancel. Also, the denominator factors, you could technically pull out an ab, but nothing's going to cancel. So this is our answer. So again, in the land of complex fractions, multiply every term by the LCD, cancel, simplify. That's it.